Welcome to Brain Vision.
So continuing on with physical chemistry, we're continuing with our work around material related to humidity and such equations. So just to offer some contextual learning, in air, the humidity is the amount of water vapor that is present. So humidity plays a very important role in our daily life and is important for the weather because the weather is depending on humidity, and without this humidity there is no weather. And it would become very dangerous to in fact live on Earth. So we have two main types of humidity. We have relative humidity and absolute humidity. So we have our temperature, ambient conditions, and the relative humidity. So from our psychrometric chart, we have the humidity ratio and the specific humidity. So the temperature of humid air in the inlet condition is 22 degrees C. Relative humidity is 50%. And again, we have our humidity ratio and our specific humidity. In 1 cubic meter, we have 35.3147 feet cubed. And then we can convert our cubic meter to cubic feet. So 2830 meters cubed is 2830 meters cubed multiplied by 35.3147 divided by 1 meter cubed, feet cubed. That gets rid of our units, of course. So then we have 9.9 times 10 to the 4 feet cubed. So you can calculate the mass of the air at the inlet using the following equation. Mi is equal to V volume over Vi bracket 1 take away Wi. So we sub in some values for this. Mi is 9.9 times 10 to the 4. Divide that by 5.5 times 10 to the minus 5. Then we multiply that by 1, take away 0.0198. We get a value of 1764.36 times 10 to the 6 pound per minute. So we can calculate the volume of air at ambient conditions using the following equation. We have VA is equal to MI VA 1 take away WA. We sub in all our values for VA. So for 2.40 times 10 to the 8 feet cubed per minute. In part B now, you can calculate the volume of water removal per minute using the following equation. VW equals VA, little va, multiplied by WA, take away VI, over little vi multiplied by WI. Substituting some values for VW and we get 84.95 pound per minute. And that's the volume of water removal. So we can calculate the time next. So we have T is equal to volume of cistern divided by volume of H2O removal per minute. That is 88.88 minutes. And then we can convert 88.88 minutes into hours. We have 1.48 hours.